Hello people, today I will be discussing on the topic optical wireless communication types and its evolution. So the contents for today's presentation is optical wireless communication OWC, why we need OWC, like the types of OWC in general, being indoor OWC's link configurations, then we will switch to outdoor OWC, the types of OWC based on transmission range, then the main OWC technologies, and the current research work being done on OWC followed by reference. So what is optical wireless communication? So it is basically a form of optical communication in which unguided visible IR or ultraviolet light is used to carry a signal. Right. So basically it's used for short range communications. However, if we are using high power lasers, we can even use this form of communication for long distances as well. So it is one of the most promising current areas of research in significant and has significant potentials for high impact results, which considerably changes the wireless market, which is currently mostly dominated by RF technologies. So why would we use OWC? So like what are its advantages over the generic RF technologies which we are having as of current day? So OWC is considered as the next frontier of high-speed broadband connections due to its unique features, namely extremely high bandwidth, right, ease of deployment, then tariff-free bandwidth allocation, low power. It's having abruptly half of RF frequency systems. Then it has less mass, half of RF systems, small size, one-tenth the diameter of RF antenna, and improved channel security. Right, so it has emerged as a very good commercial alternative to existing RF communication due to all these reasons. It is capable of transmitting data up to 10 Gbps and voice and video communications through the atmosphere or free space. So in general, there are two types of optical wireless communication, indoor and outdoor. So focusing on the indoor optical wireless communication, as from the name you can clearly understand, these are used mainly for indoor activities. Right, so these devices along with the drive circuits are much cheaper as compared to radio frequency equipments or existing copper cables. Further, indoor OWC is inherently secure technology since the optical signals do not penetrate through walls. So unlike electromagnetic waves, EM waves or used by the Wi-Fi signals, right, so they can penetrate via the walls, but in case of Wi-Fi or for the optical wireless communication, so as light is not penetrating walls, right, even if a hacker is present in some different room or cannot access the light itself, right, so in that cases OWC is highly secure. Eavesdropping can't be done if some hacker is sitting on a different room as compared to where the signal is receiving, until and unless the misconduct is being done on the same room itself. Right, then what are the link configurations of indoor OWC? The link configurations of indoor OWC are the classification of an indoor link depends mainly upon these two factors: transmitter beam angle or the degree of directionality, and the second is the detector's field of view, whether the view of the receiver is wide or narrow. Right, so based on this there are mainly four types of link configurations. First one being directed line of sight, that is the transmitter and receiver are directly on the line of sight to each other. So this configuration is good for point to point link establishment. Coming to the next category, it's non-directed line of sight beam, where the transmitter and receiver are not directly on the line of sight. However, the range of the transmitter is such that it could easily like the receiver can easily get information as it is as the link is suited for point to multi-point broadcast applications. Right, now coming to the third category, it's diffused link. Diffused link is the transmitter and receiver are not in line of sight. However, the transmitter is emitting a wide beam of IR energy like towards any obstacle or a ceiling in case, or any like reflective surfaces from which the optical signal gets reflected and it's received at the receiver. The final category being multi-beam quasi-diffused link. So in this type of link, a single wide beam diffuse transmitter is replaced by a multi-beam transmitter, also known as quasi-diffused transmitter. The multi-narrow beams are pointed outward in different directions, and these optical signals are collected by angle diversity receiver placed on the ground. So what this angle diversity means, that like the signals are transmitted in such a way, like keeping such an angle so that the individual beams which are transmitted are completely uncorrelated to each other. So followed by our outdoor OWC as per the diagram, as you can see. So this is a form of outdoor OWC. It is also known as free space optics or free space optical communication, and they require line of sight between transmitter and receiver for propagation information from one point to another. Here the information signal from the source is modulated at the optical carrier, and this modulated is allowed to propagate through the atmospheric channel rather than using optic fibers or like any other form of cable technology, right? Then ground to satellite optical link and satellite to ground optical downlink involve propagation of optical beams through the atmosphere. So like this is a basic block diagram of OWC or FSO communication, where you can see that the message is transmitted, it is received at the modulator, which modulates the signal, then followed by a drive circuit or driving circuit, then a laser, and the transmit telescope to transmit over long distances. Post that, it goes through the atmospheric channel, where these are the atmospheric effects, space loss, optical background noise. Then it is received at the receiver, where there is a receiving telescope, optical filter, in order to filter out the exact spectrum required as per the QoS requirement, that is the quality of service requirement, then followed by photo detector, and then there is post detection processor, which finally gives us our estimated message, right? So based upon transmission range, there are five types of optical wireless communication. They are ultra short range OWC, used for chip to chip communication, short range OWC, used in wireless body area networks or wireless personal area networks. Then there is medium range OWC, which is used in indoor IR or visible light communications for wireless LANs, and inter-vehicular and vehicle to infrastructure communications. Followed by long range OWC, which is used in terrestrial communication between two buildings or metro area extension, as we just saw previously. This is an example of our long range OWC. Then followed by ultra long range OWC, which is used in ground to satellite or satellite to ground communications. However, there is one drawback here, is that in cases there is like for ultra long range cases, if there is clouds or smog or fog, in that cases it might cause like an obstruction to the optical rays, thereby the signal quality may reduce, right? Followed by what are the main OWC technologies. The main OWC technologies are free space optical communications, visible light communications, optical camera communications, wireless network with light, which is also known as light fidelity Li-Fi. So the current research work being going on, I have mentioned two such research work which is currently going on. They are integration of Li-Fi with cognitive radio. So during heavy traffic loads, there is insufficient spectrum to cope up with requirements of the users in the network. However, with this integration, that is like if we are considering in scenarios in the upcoming 10 years when the number of users are very high as compared to the spectrum band of the RF, it might be such that for proper utilization, even after proper utilization, we are unable to allocate spectrum bands for users. So in that case, we can utilize the optical spectrum. However, we can merge Li-Fi with cognitive radio in cases such that when RF users are primary users and secondary, there is no spectrum band left to be used for secondary or cognitive users. In such cases, the optical spectrum can be allocated to the secondary users such that they can utilize seamless communication. The next research work on this topic on OWC is OCC, which is optical camera communication. Like, it employs either a single or multiple camera setup at the receiver, which can now be found in most mobile devices, right? So the existing LED fixtures and widely used cameras, which are cheaper and off-the-shelf devices, can be employed in OWC. So instead of using like specific cameras, we can simply use the cameras present in our day-to-day cameras present in the devices which we use on day-to-day stuff. So while the majority VLC systems are limited to utilizing the visible light spectrum, OWC employing different types of camera can utilize the entire light spectrum from visible light, NIR, to UVC band, right? So the camera captures images or video streams of the intensity modulated light sources, that is a single LED, multiple LEDs and digital screens, and extracts the information by means of image processing. The camera based OCC can be used in both indoor and outdoor environments for a range of applications. So these are my references. I have referred from Willy Anugrachari, Yon Ho-Chang, Zabe Ghasem Louis, Navid Bani Hassan's optical camera communication principle modulations, potential and challenges. And then I have also followed Hemani Kaushal, VK Jain, Subrat Kaur's overview of wireless optical communication systems. I have followed Harold has Jafar El Meghani and White's optical wireless communication book as well. And I have also referred from Ridhima Verma's Nurturing Wireless Communication Coalition of Cognitive Radio with Li-Fi.